Assalamualaikum warahmatullahi wabarakatuh. Hi everyone, my name is Naila Fathma Firmana and here's my partner.
My name is Syakirana Fitri Amalia.
We are from Islamic State Senior High School, Kudus. And today we are excited to present our project entitled
An in silico approach for identification of novel inhibitors as potential therapeutics targeting HIV-1 viral infectivity vector from Parijoto or Medinilla speciosa.
Did you know that human immunodeficiency virus or HIV has claimed 40.4 million lives with continued spread worldwide? Compared to HIV-2, HIV-1 is considered much more dangerous with its global distribution, higher transmissibility, and tendency to quickly progress to AIDS.
According to Lab Analytics in 2000, human immunodeficiency virus type 1 protease is one of the most challenging targets of antiretroviral therapy used in the treatment of people with AIDS, because it plays an important role in viral replication.
Meanwhile, on the slopes of Muria Mountains in Kudus, Central Java, a signature plant called Parijoto or Medinilla speciosa is growing. In fact, this plant has not been widely recognized and studied, but it actually has various potential biological benefits. One of them is as an antiviral.
This study used in silico methods to identify potential therapeutics inhibitor for HIV-1 virus infection that are derived from Parijoto plants or Medinilla speciosa,
as well as to support UNAIDS and SDG3 programs. The objectives of this research are: first, to identify compounds in Parijoto fruit or Medinilla speciosa that potential to inhibit HIV-1 protease.
Second, to determine the binding energy affinity of compounds in Parijoto fruit or Medinilla speciosa as ligands to the HIV-1 protease receptor through molecular docking.
The first step we do is the sample preparation. The Parijoto fruit is washed, dried, mashed, and extracted by maceration method using ethanol solvent.
Second is the analysis of gas chromatography mass spectrometry or GCMS. According to Al-Rubai et al. 2017, this gas chromatography is able to read compounds with the lowest concentration so that plant secondary metabolites can be identified.
Third, we downloaded all the test ligands that were identified in the GCMS results through the PubChem web server.
The next process is the receptor preparation. The HIV-1 protease is downloaded from the protein databank with the code 3F43 and we use BioVia Discovery Studio Visualizer to remove water molecules and other non-standard residues, also to separate the receptor with its native ligand. And then, we edit hydrogen atoms using autodoctals.
The fifth is the identification of active site residues on HIV-1 protease receptors using the Cas2 web server. And the sixth process is the molecular docking validation. The validation process was carried out to determine the location of the native ligand coordinates docked to the receptor, and then identify the RMSD value using PIMO.
And then we conducted the molecular docking between the receptor and the test ligands. This process was carried out using autodocking integrated in parallel with the same procedure and coordinates as in the validation process.
And the last process is the data analysis.
The laboratory of Universitas Islam Indonesia was successfully detected 3 peaks with 6 possible compounds that have different level of similarity index in the GCMS chromatogram, which are hydroxymethylpropionamide, tripentyl alcohol, dimethyl oxalate, propanedioic acid dimethyl ester, chloropendipiperidino dihydroimidazole, and 3-methylapenandrine.
After that, the molecular docking between the receptor and the 6 test ligands was conducted to determine the ability of Medinilla speciosa as an HIV-1 protease inhibitor. The strongest binding was obtained by chloropendipiperidino dihydroimidazole with a binding affinity of -10.0. This binding affinity value is equivalent to the standard ligand ampreenavir and is the best binding affinity value compared to the other test ligands. Meanwhile, the weakest binding is owned by dimethyl oxalate with a binding affinity of only -3.9. Other than that, the chloropendipiperidino dihydroimidazole also has the highest number of amino acid residues compared to the other test ligands.
Next is Lipinski rule of 5 analysis. According to Lipinski et al. In 1997, this rule is used to screen compounds that have good oral bioavailability and permeability potential. The rule of 5 states that poor absorption and permeation more likely when there are more than 5 hydrogen bond donor, molecular weight more than 500 Dalton, log P is more than 5, and hydrogen bond acceptor is more than 10. Therefore, all the test ligands are checked to ensure compliance with this rule.
Based on the results, it is proven that all 7 ligands have very high bioavailability with only one highest deviation, which is in the compound 3-methylapelandrin, while the other compounds successfully fulfill every rule of 5 reiteration.
Therefore, the compounds from Medinilla speciosa show good compatibility as they fulfill Lipinski's rule of 5, indicating potential similarity to orally active drugs. The last is ADMET prediction that is used to predict pharmacokinetic and toxicological characteristics of test compounds that potential to become drug candidates.
Based on the HAA percentage, there were 3 compounds in the very good category and 3 compounds in the medium category. In CaCO2, all test compounds have a moderate level of permeabilization. Then, PBB prediction shows that all test compounds have low binding, so they don't have the potential to cause toxicity. Based on the PBB prediction, the test compounds have penetration level that varies from low, medium, and high. Meanwhile, on toxicity, all test compounds have mutagen characteristics except for 3-methylapelandrin. And there's only one compound that is carcinogenic to mouse and rat. With those results, it can be assumed that the compounds in Medinilla speciosa are potential candidates for HIV-1 protease inhibitors.
Based on the results and analysis, we can conclude that first, the secondary metabolite compound from Medinilla speciosa that has the best potential as an HIV-1 protease inhibitor is chlorpenyl piperidinodehydroimidazole.
Second, the compound with the best binding energy affinity is chlorpenyl piperidinodehydroimidazole with a value of -10.0, where this value is equivalent with the binding energy affinity of the standard ligand emprenavir.
We hope that this research can provide information about potential compounds from Medinilla speciosa and contribute to the development of innovative therapies to treat HIV-1 virus infection.
So, this is the end of our presentation. Thank you for your kind attention. Wassalamualaikum warahmatullahi wabarakatuh. Bye-bye.